Okay, I've got two more homework problems to go through. So in the first video, I did the two inclined plane problems, these two, number 1 and 2. And then in the second video, I did number 3, and then I did number 5 because I spent a while on 3. So now we're going to look at number 4 and number 6. Hopefully, we'll have time to do both in this video. And these two, again, they're both forces problems. They're just a little bit different way of looking at some problem solving. Okay. So here we're given a 2 kilogram object, and then it's got these forces acting on it. So it's got a gravity and normal force. It's sliding across the surface. So those are netting each other out. They're balanced. It's got a force of friction, and it's got an applied force being push or pull, maybe, don't know, doesn't really matter. And they're asking, what is the speed of the object? What is the velocity of the object at 3 seconds? How would we do that? So let's start with some things we can go ahead and get. All these individual forces are figured out for us. So we know that our F net, in the case of this problem, is going to be our applied minus our friction, because this is sliding across a surface. So I got applied in one way, friction in another. So that's 28 minus 4 is 24. Sorry, I couldn't think for a second. It's early, so 24 newtons. Okay. And then I can get my acceleration, 24 newtons divided by 2 kilograms, because my mass is given. So 12 meters per second is my acceleration. Okay. If I want speed, I'm going to have to go back to a kinematic equation. And there are going to be some connections occasionally between dynamics and kinematics problems. That's one thing that we'll talk about more next week as we try and finish up this dynamics unit. But you could occasionally be asked for velocity or displacement, and you'd have to go back to our equations. I don't have the equation sheet handy, but this one is just asking for velocity. It gives us a time. We know our initial is at 0 because it says it's at rest at time 0, and we've just gotten our acceleration. So this one seems to make the most sense because we don't care anything about displacement here. So there's no reason to use either of the other two. If you remember, we had 3 kinematic equations. What we want is this speed, this final velocity per se at 3 seconds. So that's going to equal 0 plus 12 times 3. 12 is my acceleration. 3 is my time that I'm interested in. Okay. And so I'm going to end up with 12 times 3 is 36 meters per second. Okay. So that is a connection between dynamics and kinematics, and we will talk about that. Hopefully we'll have time to spend a day on that next week, but I want to go ahead and throw that one in here just to try and get us to think about that a little bit. Okay. All right. Last one. So here's another table where we're given force of gravity, force of friction, horizontal applied force, and a normal force. So we got another object that's 2 kilograms, and it's sliding across a horizontal surface. And they want to know which of the following could represent the magnitude of the net force, and you're supposed to pick 2 answers. Okay. So remember, when we do F net, we're really getting, I've referred to it a few times as an absolute value. Okay. And then we see our diagram gives us the directions of our forces. Okay. So net force, it could be our applied force minus our force of friction. That's the way we've been doing our problems. Okay. So we would have 8 minus 2 gives me 6 newtons. Okay, that's one of the ways we've been doing this is more of, like I said, an absolute value. We're just taking one force and subtracting the other force. So we got it one direction, we got another direction. This really doesn't tell us anything about direction necessarily in the problem. Okay, so 6 is one answer that we could get. The other answer that we could get is 10, and that's if we add both of these. So we could have a situation where these two are added together. And that's going to be a really specific example where you have what we call rolling friction. We haven't really talked about that much, and it's not super important. But I did want to mention it just so you've seen it. This would be where your friction and your direction of motion are the same, and this would really apply to a rolling object, which this could be. Okay, we don't know for sure. It says it slides, but it's possible that it could be rolling. Then that's just a really specific type of friction, and you're probably not going to see that very much, but I wanted to mention it just in case. So then we would be adding these two. Our other two answers, if we use either of those, then we're going to have to be adding up more than just these two forces in the horizontal direction. And so we really can't get to these two answers in this scenario and what we're told, because we know that these two, normal and gravity, are going to be vertical, right? We've got gravity, normal. They're balanced because this is on a surface. So we've got some kind of applied friction, and we've got a force of friction. In the case of the 6 newtons, maybe in this opposite direction, and then in this really specific case, they would actually both be in the same direction. Okay. So that one's a little different. I just wanted to throw it in there because it might be something that would come up. I kind of doubt it, but since we are covering friction throughout this dynamics unit, I wanted to mention it. So, okay, so that's all the homework problems.